So hi everybody, my name is Volker Simonis. I'm working for SAP in the SAP JVM team. We are involved in the OpenJDK project since about 10 years. As Mark put it, we contributed some ports, AAX, PowerPC, S390. We're also contributing a lot of bug fixes, serviceability features and stuff like that. Well, recently there has been a lot of discussions about the future of Java. Is Java still free? What can we do? So hopefully this talk can bring some light into the Java story. So all these slides are on GitHub. I will show this slide at the end one more time, so you can take a picture if you want. I have a lot of links in my slides, so you can use it as a starting point if you're interested in these topics. So let's start very easy. What is Java? It's actually three different things. It's a programming language, a virtual machine or runtime, and a class library and API. And all this together makes up the Java platform. And but Java is also a trademark. So don't be afraid, this is the only blinking slide I will have. But this is very important because, well, Java trademark is owned by Oracle, and only they can use it. You can buy commercial license to use Java, but otherwise you stick to OpenJDK, which is not bad. So what is the Java community process? It was mentioned in Mark's talk as well. It's actually a mechanism, a formal mechanism for developing Java specifications. It's also around 20 years old now. And it's actually no standards body, so some people think it's like ISO or ANSI or stuff like that, but it's actually more of an industrial consortium, and it's still dominated by Oracle, which is okay. Yes, and the JCP develops Java specification in so-called Java specification requests. And a Java specification request creates a specification, a reference implementation, and a TCK, which is a technology compatibility kit, which has the duty to verify that alternate implementations conform to the specification. So this is actually a good thing, I think, and it's quite unique among the different programming languages that we have that Java and the Java ecosystem has very good TCKs. But there is also problems with this, and we will see that. So I explained what a TCK is. The JCP has often been criticized as being just a rubber stamp organization, and that's partially true, but there have been situations, maybe the older here in the audience will remember the Apache versus Sun problems, where the JCK postponed the Java 7 delivery for a lot of time, and some people say that this was even the reason why Sun finally open sourced its Java implementation into OpenJDK. And just recently, the executive committee rejected the first version of the JSR 3776, which was the Jigsaw, and forced the OpenJDK community to more thoroughly hear the community and bring some more changes to Jigsaw before they were finalized and released. So there is some advantages in having such a body. And actually, the JCP cared for three different Java platforms. We had Java EE, Java SE, and ME, which is a micro edition. And I already said it, we had Java EE, so Java EE has actually moved out of the JCP out to the Eclipse Foundation, and it's now called EE4J. Again, this is part of the reason for this name change is because Oracle owns the trademark on Java, so it cannot be called Java EE anymore. It has its new name, EE4J, which is quite nice, I think. JCP still cares about ME, but ME is basically defunct. It hasn't happened anything there in the last few years, and I don't see any actions there, which is sad, but it's how it is. So currently, JCP is actually only stewarding the Java SE development, and that's also what we will talk about in the future, in the second part of my talk. So what is the JCK? So JCK, Java Compatibility Kit, it's actually the TCK for certifying Java SE standard edition conformance. But unfortunately, the JCK is only available to commercial Java licenses or to the OpenJDK community, which signs a OpenJDK Community TCK License Agreement, so-called OCTLA. But the problem is that with this, you can only certify GPL licensed implementations which are substantially derived from the OpenJDK. And this term, substantially derived, it's a little fuzzy. For quite some time, Oracle was handled this very freely, but recently there have been some problems. Maybe you have read that Oracle withdraw the TCK from the Adopt OpenJDK project, which used it to certify its OpenJ9 builds, which used a different virtual machine, the OpenJ9, combined it with the OpenJDK class library to create an alternative Java development kit. I remember it very well when we were here like many years before, 10, 8, 9 years. There were other alternate VM implementation, GemVM, IkeVM, I don't know, there were a lot of others, and they all used the TCK to certify, and it was considered substantially derived if they used the OpenJDK class library, but obviously this is changed with VMs which are by a competitor like IBM. Another problem is JCK is that it's closed source. So the OCTLA is actually an NDA agreement, so you cannot openly speak about the results or the problems. You can only communicate them back to Oracle. And while it's, I still think that it's a good test kit for compatibility, it's also, you have to be aware that it's quite complex. It contains more than 140,000 tests. And the JCK6 user guide, which is the only one which is available online under the Apache license, it's about 300 pages, which describes how to certify VM. So you can have a look at it. Certification is quite complex. And you have to be reminded that conformance is not quality. So that the JCK checks that your implementation is conforms to the specification, but it doesn't mean that your certification is high quality or it's stable or whatsoever. So you need different tests for proving quality. So what's the JEP process compared to the JSR process? JEPs were mentioned. The JSR, as I told you, that's the Java specification requests, which are the means how the JCP creates new specifications. And recently, there is only one umbrella JSR for new Java releases. So all the features in Java are developed within the OpenJDK as JEPs. So the last JSR, which specified a part of the SE platform, was the Jigsaw, the modularization JEP. Since then, we only have umbrella, so-called umbrella JSRs, which contain all the JEPs, but JEPs are not developed within the JCP, but in the OpenJDK. So JEPs, JDK enhancement and proposal process, this is somehow still dominated by Oracle, because new JEPs require endorsement and funding by group leads, and currently all the group leads are from Oracle. You saw the picture. I mean, Oracle also, 80% of the developers are from Oracle, so that's also maybe normal. Hopefully, more and more contributors from outside will show up and maybe even become group leads to change that. And the OpenJDK lead, who sits here, is the ultimate instance who decides which JEPs get included into a roadmap. So we have three kinds of JEPs. SE, these are JEPs which have to be approved by the JCP in the umbrella JSR. So SE JEPs change the Java Platform Standard Edition specification. Then we have JDK scoped JEPs, which change the interface, like add new command line options, add new classes, which are not in the Java namespace, maybe in the JDK namespace, or ComSun or other classes. And we have pure implementation JEPs, which maybe add a new GC, or which add a new JIT compiler, or improve the JIT, or add a new platform port. So these are actually not visible through the interface. You see the functionality, maybe faster, but you don't see the change in the interface. And this is the same slide which Mark showed. I think mine is nicer because I have colors. But what I wanted to show is, so the green ones are actually the SE scoped JEPs, so which change something in the standard. So you see, for example, the process API update. This really added some new classes, Java, Lang util process, and functions to existing classes. Then we have the yellow ones, which are the JDK scoped. So, for example, we have a new Doclet API that's not standardized by the JCP, but it's still some classes which you can use in your project if you want. And then we have the white ones, which are purely implementation scoped JEPs, like, for example, the new build system or stuff like that, or the Linux S390 port, which was contributed by us. This is the same picture for Java 10, 11, and for 12. So you see, for example, 10 had very few SE scoped changes, local variable type inference, but this was quite visible change. And Java 11, which is a long-term release support, this brought in, for example, the new HTTP client as a standard. So when we go back, you see that in 9 we had the HTTP client as incubator module, which was not standardized. So we'll come to the difference between incubator modules and preview features in a few slides. Actually, just right now. So what are preview features in incubator modules? Incubator modules are defined by a JEP 11. So the reason behind them is to ship non-final APIs with a JDK, and in order to get feedback from the developers, improve this, and finally standardize them. So this is a pure open JDK mechanism. So other VM implementers don't have to follow this. So for example, if the Oracle JDK creates a new incubator module and you are developing your own JDK, Java Virtual Machine, you don't have to also provide such a module. These modules are in the JDK incubator module or package. And actually, the reason behind this, you bring in an incubator module in a release, and then it has to either be finalized and standardized in the next version, or at least substantially improved. Otherwise, it has to be removed. So it should be like a one-shot, like a one-shot example. You bring it in. If it's acknowledged by the community and people like it, you can specialize. You can you can finally standardize it, or otherwise you can improve it if you get a lot of feedback, or just remove it if it's not required. As I told you, this is not part of Java SE. And then with JEP 12, the processing introduced the so-called preview language and VM features. So this is actually a feature which is fully specified and implemented, but it may not be permanent. And but this will be part of Java SE. So a preview language or VM feature will have its own TCK, and everybody who pretends to implement this specific SE version will have to also implement these preview features. And they have to be enabled by the -- enable preview flag. So by default, they will be switched off. And again, if there will be positive feedback, they can be made permanent. Otherwise, they can be removed in a follow-up release. Okay, so OpenJDK was mentioned here before. It's a Java SE reference implementation since Java 7. It's under GPL plus class path exception. The class path exception saves you from the viral nature of GPL, so you can run your applications on the OpenJDK without getting infected. Oh, sorry, I didn't have to say that. You have to inform me about your... Most of the people didn't hear anyway. But until OpenJDK 8, OpenJDK was a source-only project. So OpenJDK only provided the sources for the OpenJDK. Since Java 9, Oracle builds OpenJDK builds on the GPL plus class exception, but only for Linux, Macs, and Windows. So they don't build it on all the platforms supported by the OpenJDK, which has a much broader platform support. And they only do it for 2 updates, so for 6 months. But there are a lot of binary distributions from various other vendors, and I will present most of them, hopefully, at least all I know of. And they do different versions of the OpenJDK on different platforms, for different platform versions. You can choose the one you want. And then we come to the OpenJDK updates project. So this is actually the place where old releases are maintained. So JDK 6, currently maintained by Azul, was previously maintained by Red Hat. JDK 7, maintained by Red Hat. 8, so I updated the slide yesterday evening, by Andrew Haley, Red Hat, very fine. JDK 9 updates, not maintained anymore in the OpenJDK project, but we will see there are other vendors who still support JDK 9 updates. It's Azul, for example. JDK 10, a short-term release as well, abandoned in the OpenJDK because nobody stepped up to take over the role of the updates project lead for JDK 10. Yes, and we all wait for Andrew to raise his hand for JDK 11. Okay, so Oracle JDK, it's derived from the OpenJDK. I would say substantially derived from the OpenJDK. It had non-Java SE add-ons until Java 8, like JavaFX. WebStart, this is something which is very confusing for people who are now switching to OpenJDK-based distributions, because many people thought that JavaFX is part of the SE standard. I know it never was, and it was never explicitly mentioned, but for many people, Oracle JDK was Java. It actually is Java, but not the Java SE platform. And it had commercial features like flight recorder and mission control, which you could only use if you had a support contract. So until JDK update 8, update 202, which came out, I think, 2 weeks ago, the Oracle JDK was under the Oracle binary code license, which allowed you to use it productively. It allowed commercial use, but it still had a field of use restriction, and this is also something many people were not aware of. So, for example, you've never been allowed to use the Oracle JDK in embedded devices, for example, on mobile devices and stuff like that. Now, after Java 8 update 202 and for JDK 11 and ongoing, Oracle JDK is under Oracle Technology Network license, which is for personal development use, but you cannot use it in production anymore. Okay, so this is one of my favorite slides. It may look a little complicated, but this shows the license flow. So in the middle we have the OpenJDK, which is under GPL class bus exception, and because Oracle is actually the copyright owner of the sources, they have the right to relicense it, and they actually do it. They do dual licensing, and for example, sell the OpenJDK licenses with a commercial. They just switch the copyright headers and sell it, for example, to companies like SAP or IBM. So SAP and IBM, they are free to do their own commercial Java distributions, like we do, for example, SAP JVM. But SAP also contributes back to the OpenJDK. I mentioned that. And we do that under the Oracle contribution agreements, which is actually a copyright sharing agreement. So we still keep the copyright on our contributions, but we also share them with Oracle. And this allows Oracle to then relicense our contributions to the OpenJDK to others. So IBM can profit from our enhancements. We can profit from IBM's enhancement. And then everybody, also SAP, for example, we not only build a commercial version of Java, but we also build a pure OpenJDK-based Java distribution called Submachine. Other companies like Azul, they build the Zulu VM from it. Amazon builds Corretto, Red Hat also. They just take the plain OpenJDK and build their binary distributions out of it. And they all contribute under the Oracle contribution agreement. Okay, so just a quick overview of the Java versioning. So we had 6, 7, 8, but the update scheme was quite complex in the past. So we had 8 up 10, 20, 40, 60 for limited update releases, which introduced new features. Then we had critical patch updates, CPUs, which were odd numbered, like 8U25, 31, and so on. And we even had patch set updates, which only contained the security fixes of a critical patch update, because critical patch update could also contain non-security fixes. So with JEP 223, a new version scheme was introduced with Java 9. So we get 9 like before, 6, 7, 8, but then the update releases were the third number, like 901 was the first update release, but then the second update release was called 904. So why 4? Because actually this third number denoted the months after the initial release. So first update actually means it was released a month after 9 was released, and 4 was released 3 months after 901 was released. So this was a little confusing. So with Java 10, again, we got a slightly change in the versioning scheme. It was also adapted to the new time-based release. And we had, actually it looks pretty the same, but you may realize that now the first update is called 1001, the second one 1002, and so on. There was also a Java vendor version introduced. This is a system property and also a tag which vendors can use to denote their version numbers. So this was 18.3 for 10 and 18.9 for 11. You may guess what is this? This is the year and the month. So actually this number comes from a very initial proposal of this JEP, where there was a proposal to do it like with year, like Ubuntu with year and months, but nobody really liked it in the community, so we switched to the scheme we have now. But obviously Oracle liked it, so they somehow wanted to preserve it. But yes, and we also added the notion of LTS. So the version string can now also contain LTS if it's an LTS release. But in the end, with this bug, they finally also want to get rid of it, because obviously nobody uses Java vendor version. For example, we for Submachine don't use it, and other vendors as well. So it's now proposed to remove the Java vendor version from the version again. So how does this look like when we have Oracle JDK on top and the OpenJDK on the lower end? If you run Java minus version, you see the first difference is that Oracle JDK also is built from exactly the same sources, but by Oracle and called Oracle JDK. They have the right to call it Java, while the OpenJDK builds under GPL, they are just called OpenJDK. Then we get the version, and this is the vendor version, which is still in 4.11. And we get also the build numbers and the version of the runtime, which is usually the same like for the class library, which is the same like for the runtime. But isn't there something missing? This is Java 11, it's the LTS release. I'm not sure if Oracle was not sure if they should make an LTS out of 11. I suppose they just merely forget to add this string, because then with 11.01 and 02, they added the LTS string to their release. While you can see that OpenJDK has no LTS tag, because as I told you, LTS, it's not an attribute of the OpenJDK. It's vendor or implementer specific. So different vendors can decide to do LTS or not, but it's not tied to the OpenJDK project, actually. So some words about the release model. Yes, we saw that before. We have releases every 6 months and updates a month after the first release, and then every 3 months thereafter. OpenJDK, so Oracle provides 2 of these updates for all the releases. So actually, by default, all releases are short-term releases in the OpenJDK. Some vendors version scheme is actually intended for enhancements, but it's not used currently. And the OpenJDK vulnerability group, which we thankfully have now, cares for and coordinates security fixes which go into the update releases. So a very quick overview of the various OpenJDK distributions which we have. We have IST from Red Hat. It was the first actually OpenJDK distribution. They built the first build harness which enabled it, which made it possible then 11, 12 years ago to build OpenJDK sources with only free software. They are the base of Linux for OpenJDK packages on most Linux distributions. And nowadays they have a lot of extra features which they downport to all the releases, for example, like Shenandoah, IST Web, and they also support new platforms also in all the releases, which they also contribute upstream into the OpenJDK. But for example, R64 or Shenandoah is in OpenJDK 12 or 13, but in OpenJDK sources 8 it's not available, but on the binaries built by Red Hat it's supported. And recently I saw they also have a Windows version, so which was interesting for me, but yes. Then we have Adopt OpenJDK, OpenJ9. I put this on the same slide. So Adopt OpenJDK is actually, it's a community initiative which provides pre-built binaries. And they support both Hotspot VM and OpenJDK, or OpenJ9 VM. So OpenJ9, it's a Java virtual machine from IBM, which was open sourced in the Eclipse OpenJ9 project now. And it can be combined with the OpenJDK class library to create a Java JDK. They support a bunch of platforms, and IBM offers support for OpenJ9-based Adopt OpenJDK binaries. I mentioned it before, we have Zulu Enterprise, Zulu Embedded. This is OpenJDK-based distribution from Azure. They offer commercial support for it. They support versions from 6 to 8. They have this medium-term support. What I don't quite like is that they have like a private source model, so the sources are actually in the GPL, but they don't have public repositories. You can, of course, always request the source code of such a release, but you have to do it manually. Then we have Corretto from Amazon. They only have 8 now, but they plan to provide 11 later this year. They also have LTS support. They have Open GitHub repo with some add-on and fixes. Liberica, another OpenJDK-based distribution from Bellsoft. Also, you can buy commercial support from them if you want. Submachine, well, as you can see on my t-shirt, this is one of my babies. We also have open GitHub repos. We have some add-on downports and fixes. We only support it for our customers which have actually support contracts with SAP. They also get support from it. There is others like GraalVM, JAX, Jakarta, JamVM. There's a very good list on Wiki, so if you're interested in this, you can look there. Then we have commercial JDKs like Oracle JDK, IBM SDK, Java JVM, HP. Fujitsu also have a JDK. Excelsior Jet, it's a special JDK. It's commercial JDK, which does ahead of time compilation. Jamaica VM, it's a real-time JVM. And yes, how do you actually choose your JDK? Well, of course, you have to see which Java version is supported. You should look for a platform support, especially if you want to support all the Linux systems, for example, with all the kernels or glibc. You have to be very careful because not all these distributions run on all the Linux versions. You have to look at the support and support time frames, see if it's free or paid. And of course, you should look how your vendor is involved in the OpenJDK process. This is the same slide presented by Mark before. So obviously, somebody who is involved in the OpenJDK project could be trusted more than somebody who does everything on his own. So in the end, I would say Java or OpenJDK is alive and kicking. You have the choice which distribution to use. With OpenJ9, you even have a great alternative VM now. Competition is good. Collaboration is good as well, maybe even better. And I don't like the proprietary JCK, and I think it will become dispensable because the Java platform is quite mature now. Everybody uses the OpenJDK class library anyway, and if you don't have the possibility to speak about these things, it won't be important anymore. So that's all. My slides are available here. Thanks for listening.